So G showed me the answer here. So real quick, we're going to be talking about the test. So where the correct answer is 0 is equal to the partial derivative with respect to k times d of k plus the partial derivative with respect to L times d of L. So this, whatever this question is, I will give you full credit. Yes, you now can see the questions you got wrong with detailed feedback and solutions as to why you got those questions. Okay. Any other questions on the test specifically? So you can always take a screenshot of them. You can take what's called snipping tool in Windows, or what's called snapshot. Snapshot. No. What's it called? It's the Apple version. Snipping tool. Got a snipping name. There's one for them. Doesn't matter. You guys got questions in that?
Yeah, like there's one that was like super weird.
Okay. Isocurves? All right, so yeah, just if you have questions, problems, concerns, just please send it my way. But like I said, I mean, the average was 85%. All right, yeah, no, I will look through it. You know, maybe we'll cover it just a tiny bit in class on Wednesday, and then I'll give everybody credit for that. Okay. Thank you for bringing that up. Okay, so like I said, so we've done the Learn Smart, we've done the quiz for Chapter 8 and stuff, right? So which questions should we go through? I mean, it's pretty straightforward if you've taken economic classes before, right? But if you haven't taken any economic classes before, then this is probably a bit difficult in terms of the relationship between the demand and the supply, the perfectly competitive market, right? And how that generates a marginal revenue curve. And then we're going to choose where we produce based on where that marginal revenue and marginal cost curve cross, right? That's going to give us our Q star. And then in order to figure out where our actual profit is, we need to draw in the average total cost curve. Then we need to find a reflection of that Q star off of the average total cost curve. The marginal revenue we know is the same as the price. So in order to get this profit square rectangle here, that's going to be equal to quantity times P minus ATC. And so because of the nature of perfect competition, let's say that, there is a new study released that says that whatever this product is, if you use it, you're less likely to get cancer and die, right? So nobody wants cancer, so there's going to be a demand shift out as tastes and preferences increase. That's going to increase the equilibrium price. That's going to increase our marginal revenue curve. At our new marginal revenue 2, we're going to have a Q star that is higher than before, and we're going to have a profit that is greater than before. Because of the nature of the perfectly competitive industry, other people see this abnormally high economic profits. What are they going to do? They're going to enter the industry. If they enter the industry, what happens? supply is going to shift out. So we have S2, which is around the old price. It's going to give us a new marginal revenue curve. They're always going to produce when the marginal revenue equals the marginal cost. Huge triple star. What's going on here? There's still abnormally high profits, right? And so more producers want to enter the market until we get to some point over here. We're at an equilibrium amount. Marginal revenue equals marginal cost is going to be the bottom of the ATC curve. There's going to be zero economic profit. And that's where the story is going to end, so to speak. So it's about this interaction between the market and the individual cost. So the market supply and demand curves and the individual cost curves. And specifically how the equilibrium in the market determines the marginal revenue for the individual firm. And the information from the individual firm is going to feed back into the happenings of the supply. So we also think that, so just really, really quickly down here, I could do as many colors just so we can be quick. So if we have band here, and if we have, so there's crazy oversupply, and the cost curves are over here, then at this equilibrium, we end up with a marginal revenue, marginal cost right there. That's going to be our huge star. Go up to the average total cost. Our average total cost is here, so this is actually going to be a loss, right? Going to be a negative number. And so because of the fact that there's loss, there's free entry and exit. It doesn't cost them anything to switch out of making socks and go to making sweaters or hats or whatever the case may be. So there's going to be a shift rightwards in the supply curve until there'll be a first shift. It'll happen, and it's right here. But they're still making a loss right here, right? That Q double star. And so then there'll be a second shift, even more firms will exit until we get to that equilibrium point. The marginal revenue is exactly equal to the marginal cost. It's exactly equal to the average total cost. Questions on that? Just that dynamic, that movement in and out of the market, impacting the supply. The movement is driven by the abnormally high economic profits or abnormally, or just abnormal economic losses. So that's driving the supply curve to shift outwards or inwards, such that the resulting marginal revenue meets the average total cost at its lowest point, so where it's tangible. Okay, so we're all pretty good on in terms of the intuition and everything there. We've done some problems with it, so I don't think we necessarily have to go through the examples as long as you all don't have any questions on it. Okay, let's move right on to looking at a monopolistically competitive market. It's probably a bit more novel or difficult. So we're going to be doing chapter 8. This is the conceptual questions section. So it's 8 questions. So there's some questions and problems, right? This is going to be 8 questions, number 3 on page So how do we find out the firm's optimal output? Does the profit maximizing or loss minimizing rule, our golden rule in economics, does that change when we're looking at a monopolistically competitive market as opposed to, say, a monopoly or perfect competitive market? Does it change? Never changes. Always going to be marginal revenue equaling marginal cost, right? So we're going to find Q star where the marginal revenue, and I always do greater than or equal to, right? Because I realize sometimes that we can't produce half a unit. Good, right? And so we just want that last unit where the marginal revenue is greater than or equal to the marginal cost. So let's take a look at this graph. Where does the marginal revenue meet the marginal cost? The marginal cost is right here. The marginal revenue is right here. So it's going to meet at 7 units. 7 is going to be our profit maximizing output. What is our optimal price? What's our profit maximizing price? This is where a lot of students, because of the fact that you use this crossing, right? This where these two meet gives me the optimal quantity. A lot of students will make the mistake of also saying that this gives you the optimal price, 60. That is wrong. It's super wrong. Why? And so here's the rationale for why that's wrong. Why would you only charge 60 when the demand curve, the actual willingness to pay, shows that you can charge 130 at $7, right? So always think about, if you were running this business yourself, what price would you charge at $7? If you charge 60, you're severely undercutting yourself. You're not maximizing your profits, right? So you're going to want to go all the way up to the demand curve and use the $7 Q star, the reflection of that off of the demand curve, which gives us 130. Okay. So now we're asked about the profits. What's the maximum profits for the firm? So we have the price, we have the Q star. What else do we need? We need quantity. We have the quantity set. What else do we need? ATC, right? So we take the 7, we go up to where it hits the ATC curve. It looks like it hits the ATC curve at 110, correct? So we're going to take 140 minus, or 130, sorry, 130 minus 110, which is 20. We're going to multiply that by 7, which gives us $140 worth of profits. Now, lastly, we're asked, what adjustments should the manager be anticipating? So where is so in the same way that in the perfectly competitive world, the price always tends to the bottom of the ATC, right? Where it's tangent to the ATC. So it just touches it. It doesn't cross through it twice. It just touches it, kisses it, and moves on. A similar thing happens with the monopolistically competitive world, right? Except instead of tending towards the lowest point in the ATC, our marginal revenue curve is no longer flat, right? That marginal revenue curve is never going to hit that lowest point of the ATC tangent, right? But the demand curve will become tangent to the average total cost. And that is the kind of the resting place of these perfectly competitive markets, right? So this is all going to shift over until there's a demand curve that's parallel to that other demand curve. So there'll be a new demand curve and a new marginal revenue curve. E2, marginal revenue 2. they're going to have a new equilibrium quantity. Let's say it's right here at 4. Actually, sorry, it should be right here. So let me rewrite this. I'll show this to you in the book as well. And so that's going to be the equilibrium quantity, and there's going to be 0 economic profits, right? Because the demand is exactly equal to the average total cost there. So when we figure out, so the price is equal to 120, and the average total cost is equal to 120. So then the profit is equal to 6 times 120 minus 120, which is 6 times 0. So the manager should anticipate that the demand is going to shift to the left, right? The firm's demand will decrease over time as new firms enter the market. And so it's the same mechanism that's happening in the perfectly competitive world, but we just have some slight market power. That makes sense. So the book talks about this right here, page 257. Starts to talk about it, and then in page 258, that's where the graph is, where it shows exactly what I just did. Due to the entry of new firms selling other brands, the demand curve is going to shift over until the point where the equilibrium quantity reflected off the demand curve will be the same point as reflected off the average. So there's a trend here happening, right? In terms of, the long run equilibrium is when the demand curve is tangent to average total cost, right? And it just so happens that in the perfectly competitive world, the demand curve is exactly the same as the marginal revenue curve. This is a long run competitive equilibrium, right? Figure 8.9, 8-9 on page 2. Questions on that? What else should we do? We are the manager of a monopoly, and we're given demand and cost functions. You guys want to do that one? Sure. All right, so you are the manager of a monopoly. Your demand and cost functions are the following. We are asked, first one, what price quantity combination is Q star. That's essentially what I'm saying. So how do we find out what Q star P star? It's different from perfect competitive and monopolistic competition situation. No, same thing, right? It's always going to be, we're going to find Q star where marginal revenue is equal to marginal cost, right? We're going to set marginal revenue equal to marginal cost. So what is our marginal revenue? So remember, there's two ways we can do this, right? We can label this as P equals A plus B times Q. And we know our marginal revenue is going to be equal to A plus 2PQ. That's our algebraic shortcut. However, we are all calculus wizards here. We know that the total revenue is equal to the price times the quantity, which is equal to 300 minus 3Q times Q. We're going to go ahead and say, how does my revenue increase or change or decrease? That's a change. My quantity increases by an infinitesimally small amount. So we're going to go ahead and use our extended power rule. Remember that if we're taking the derivative of x to the 1, that ends up being 1 times x to the 1 minus 1, which ends up being 1 times x to the 0. Anything 0 is 1, so it ends up being 1 times 1, which just ends up being 1. So in the same way, if we take 300 times x, it just ends up being 300 times 1, so just 300. And then we're going to do the same kind of situation here, right? Where if we had, so let's say we had c times x squared, where c is a constant. We're going to use our extended power rule. So it's going to be c times 2 times x to the 2 minus 1. X to the 2 minus 1 is x to the 1. And so this is just going to be 2 times c times x to the 1. So in the same light, this ends up being 2 times 3, so negative 6 times q to the 1. So that is my marginal revenue. My marginal cost is going to be it's the same situation here where it's a plus b times q, and the marginal cost is a plus 2bq. Sorry. So it's the same kind of situation. You can do that shortcut. Or, you know, the same. So actually, let's get m down here is t. So this is going to be times c times q. So this ends up being 1500 q plus 2q cubed. Okay, so this is already my total cost of the design. Apologies. So I could just skip right to the total cost. So this is already my total cost. So all I need to do is just take the derivative of this. And so this is not the shortcut. I'll have to look up what the shortcut is. It's just 4q. So total cost is equal to 1500 plus 2q squared. Then the partial derivative of the cost with respect to the quantity, we just take the derivative of it. This drops out. This ends up being 2 times 2 times q to the 2 minus 1, which ends up equaling 4 times q. That's my marginal cost. Apologies for that confusion. So part of it is because this equation here is already my total cost. This isn't telling me my total revenue. It's just telling me my price. But this is telling me my total cost. It's not telling me my division. All right, so we've got our marginal revenue that we need to set equal to our marginal cost, and then we need to solve for Q. So this is going to be 300 minus 6Q is equal to 4Q. I'm going to add 6Q. Those annihilate each other. This ends up being 300 equals 10Q. Divide both sides by 10. We get Q equals 30. Now this is only half of the answer that we're asking. Okay. What's the other half of the answer? Price. So we're going to plug this into our price equation. So the price is equal to 300 minus 3 times Q. So 3 times 30. So the price is going to equal 210. Questions about that? So again, it's always find the total revenue, find the marginal revenue, find the marginal cost, set them equal to each other. Solve for Q. Plug Q back in. We are then asked calculate maximum profits. Pretty easy, right? We're just going to be plugging this in terms of revenue is equal to 210 times 30, right? Price times quantity. Cost is equal to 1,500 plus 2 times 30 squared. So this is going to be 3,300. This is going to be 6,500. And you just subtract them from R minus C profits. Oh, sorry, this is 6,300. So we end up with 3,000 even as our profits. Questions on that? All right, so we're asked, is the demand elastic, inelastic, or unit elastic at the profit maximizing price quantity combination? So do we think the demand is elastic, inelastic, or unit elastic? So the best way to do this would be to use our point slope formula for that, right? Exactly. Let's see. TR elasticity. Obtaining from demand function 79 to 83. Let's go back to 7. Elasticity is on a linear demand curve. May be found using calculus. Specifically, it's found by using whatever is the alpha on the p of x. So the partial derivative with respect to p of x times the price over quantity. So we would need to get our, we would need to convert our demand curve to an inverse demand curve, right? Because right now we have P equals 300 minus 3Q. So this is C and the elasticity. So now we need to switch this around to get Q in terms of P, right? So we're going to add 3Q. End up with P plus 3Q is equal to 300. We're going to subtract P from both sides. We got Q equal to 100 minus 1/3 P. And so then this minus 1/3, this is our alpha x, or our partial derivative with respect to P. And so to get our elasticity of a demand curve, we're going to use that, and we're going to multiply it by the price over quantity. So we're going to have elasticity qx P is equal to alpha x px over qx is going to be equal to negative 1/3. And then what's our price? Okay, it's 210. What's our quantity? It's 30. So negative 1/3 times 210 over 30. gives us negative 2.3 repeating. Now we always know that elasticity. Why am I just working around this instead of getting it? We always know that it's the absolute value, right? Because it's elasticity of demand, so we understand that it's going to be downward sloping, right? So this is going to be 2.3 repeating. So since the elasticity is greater than 1, we're going to say it's elastic. So kind of a pain in the butt since you're given the demand in the wrong format. You have to switch it around, but very doable. I'm sure that if you wanted to, you could just pick 2 points on the demand curve, right? You could have picked, some like 29 and 31 or whatever, right? But this is the technical way to do it in terms of points along the demand curve. Is it already on? Holy crap! That was wow. Okay, have a good day. See you on Wednesday. I'm so sad. We barely today. It's a bummer. Well, please email me. Let me know what questions you want from chapter 8 and 9 in class on Wednesday. And I'll do another optional class on Friday if you guys want. You don't have to come for attendance, but I'll have it to do extra problems and stuff. It's okay. It's okay. It's totally fine. I put it on YouTube. I honestly spent the first half of the class just talking about my freelance experience